So what do we have available to us for laboratory performance tests? The closest thing that we have right now to standard highway industry deicer performance tests are the test methods from the SHRP Handbook of Test Methods for Evaluating Chemical Deicers that was done back in the 1990s. These include 3 basic performance tests. We've got ice melting capacity, which is probably most commonly used, and then a couple of test methods that are used relatively rarely, such as ice penetration rate and ice undercutting. In addition to these ice melting performance tests, the industry often makes some other measurements fairly commonly. Very commonly, people will look at freezing points or eutectic temperatures as performance measures for different chemicals. Now, my suggestion to you this morning is that we need to move beyond these simple SHRP ice melting capacity test measurements or simple freezing points and eutectics. I'm not undermining the importance of either. However, I'm saying that in order to answer the more detailed questions that we have about how deicers perform in the field, such as how is deicer performance affected by all of those environmental variables? How is it affected by temperature, by traffic action, by sunlight, by pavement type, by precipitation type? What sorts of things affect the longevity or residual effect of deicer? How long it remains effective on the road? These are all things that we want to understand, and we need to move beyond just simple freezing points and ice melting capacities by the standard method. Now, fortunately, there is lots of research currently going on to better understand these things. The Clear Roads organization has sponsored a variety of studies of deicer performance, and they continue to sponsor studies of this. There are also a number of academic institutions that are doing very active research in the field. The Western Transportation Institute, the Norwegian University of Science and Technology, the Anti-Icing Materials International Laboratory in Quebec, Washington State University, the University of Waterloo. All of these organizations and universities, and I've probably not mentioned all of them, are all doing active research to better understand how deicers work and how to measure their performance. I don't have time this morning to give you an overview of all the research that's going on to better understand deicers. What I'm going to focus my attention on this morning is just talking about some of the work that we've been doing within Cargill to better understand how deicers perform and how to measure their performance. So these are the things I want to talk about this morning. I'm going to start by spending some time talking about ice melting capacity measurements. I want to talk about the limitations of the test. I want to talk about how we interpret the data, how do we make sense of it. And finally, I'm going to talk about ways that we can improve the accuracy and precision of the test method. I'm going to spend some time talking about how we might measure deicer longevity. How is a deicer affected when it's put on the road as it is exposed to continual freezing precipitation? What happens to it and how long might it remain effective? I want to talk about the important distinction between ice melting capacity and ice melting rate. And finally, I'm going to talk about the effect of pre-wetting on the ice melting rate of salt at very cold temperatures.